Okay, so this video we're looking at writing algebraic expressions, and this is a really cool lesson because, right, it might seem perhaps simple, but it's really important in understanding topics later down the line. Particularly, this is really useful in understanding how you properly solve equations. So I would definitely, even if you think, well, this seems a little bit perhaps easy or maybe not, okay, this is a really important video because when we solve equations later on, this really helps with the order in which we do things, which might not make any sense right now, but this is a really important video. So let's get into it. So normally, right, I do this in my class, so I've got example one on your whiteboards, but you can just do this on your notepad or whatever you want to. So whatever you think, first of all, I would say, right, how would you write this algebraically on your notepad or whiteboard or whatever? I'm thinking of a number and I add 5 to it. How could you write that algebraically? Well, the way that we would do that is something like this. We would say, I'm thinking of a number, and this number we can represent using a variable. This number, I don't know what it is. It could be 3, it could be 100, it could be a million, right? It could be -2. That number, I don't know what it is, but I represent it using some variable, okay? And in this case, I've chosen that variable to be the letter x. You could have used y, you could have used k, you could have used a question mark, you could have used a dog, right? I don't know what I'm drawing here, right? But anyway, I've chosen x because that's a letter that we commonly use in maths, okay? But you could use any letter. So I'm thinking of a number, which is the x part, and I add 5 to it, so hence the +5. So that is it, okay? And like I said here, you can use any symbol or letter to represent that number. So maybe nothing too crazy there. How about this one? I take the number 5 and I add a number to it. So you can give that one a go. Well, you would write it something like this. I take the number 5 and I plus a number to it. And again, I've used the variable x, but you could have used any letter or symbol, okay? So there we go for the first two. Now, a really important idea. Do x plus 5 and 5 plus x, what you've just seen here in the red boxes, do these mean the same thing? And the answer is yes, okay? Because, for example, if this value of x, if we were told that x was equal to 3, for example, well, the first one would be 3 plus 5, which we know is 8. And if x is 3, well, over here we've got 5 plus 3, which is still equal to 8. So you can see no matter which way around the x and the 5 go, when you're adding, you get the same answer. So we have x plus 5 and 5 plus x are commutative. This means no matter which way around the x and the 5 go, because we're adding... Oh, what's happened there? Sorry. This keeps happening. What has happened there? What has happened? Okay, sorry. Because we're adding, it doesn't matter which way around things go. Because if you have something like, I don't know, 10 plus 2 and 2 plus 10, right? They both are equal to 12, aren't they? They're both equal to 12. So it's just saying that addition, right, is commutative. No matter which way around the things go, your numbers or variables or whatever, you get the same answer. That's a really important idea. Okay, back on the whiteboard or your notepad or whatever, how would you write this? I'm thinking of a number and I subtract 2 from it. Okay, something like this. Right, the number, again, I've used the letter x. I subtract, I take away 2. There we go. What about I take the number 2 and I subtract a number from it? How would you write that? Give that a go. Well, you'd write it like this. I take the number 2 and I subtract, I take away a number from it. And that number, again, I use a variable to show that number. Again, I don't know what that number is. It could be 1, it could be 3, it could be 100. But I'm just representing that number using a variable that can vary in value. Yeah? So there we go. And now, this time, right, do x take away 2 and 2 take away x mean the same thing? And I would usually ask in class, right, somebody give me a value of x. So someone might say, okay, x to be equal to 4. Well, if x was equal to 4, okay, if x were equal to 4, well, we would have 4 take away 2, which is equal to 2. And then we would have 2 take away, if x is 4, 2 take away 4 is negative 2. And you can see that 2 is clearly not equal to minus 2. So we say x take away 2 and 2 take away x are not commutative. Or in other words, subtraction, okay, it isn't commutative. The order matters. Yeah, you can see if we do 4 take away 2, that is different to doing 2 first take away 4. So the order does matter for subtraction. So here, these two things are not the same. The order of these matters. Okay, example 3. How would you write this? I'm thinking of a number and I multiply it by 6. And often I would say, right, raise your boards to my students and they might say, well, you've got a number, x, and you're, let's do it over here. You've got a number, x, and you're multiplying it by 6. I would say, okay, that's correct. That's not wrong. But we now know we can write this in a better way. And someone might say, yeah, you're timesing in algebra. You just clump it together. So you would write x, 6. That's not wrong, but again, it's not perfect. Okay, we like to go with the number first, so 6x. So all of these, right, they are correct, but this is your best answer because you've got 6 times x with the number before the letter. So 6x or any other letter, okay, would be good here. So that was how you would write this one. Okay, example 4. I'm thinking of a number and I divide it by 2. How would you write this? Well, sorry, I should have said giving you more time. The way you write this is like this. This means a number, x, divided by 2. If you wrote that, that is not incorrect. But in algebra, as we've seen previously, right, if we're dividing, we can write it like this. This means divide, x divided by 2. It's just a better way of writing it. Okay, so this is a good answer. And then the one below, I divide 2 by a number. How would you write this one? Well, you might say, well, 2 divided by x, but we've just said, like if you're dividing in algebra, you would write it as this 2 over a number, like this, okay? And then again, right, do x divided by 2 and 2 divided by x mean the same thing? And I might say again, in class, somebody give me a value of x, and someone might say, well, x is equal to 10, for example. And I say, okay, well, if x is equal to 10, we've got 10 divided by 2. Well, 10 divided by 2 is 5. And over here, we might say, well, what's 2 divided by x, which is 10? And 2 divided by 10 is 0.2. And you can clearly see that 5 is not equal to 0.2. So we say division, or x over 2, and 2 divided by x are not commutative, which is really, really important. Okay? So in summary, okay, we went through 4 examples. The first one looking at sort of addition. So example 1 was looking at addition problems. We saw that, I'm not going to read them out again, but you can read them yourself. We saw the first one we could write as x plus 5 and 5 plus x. And we said that these are commutative. These are commutative. In fact, I think I'm going to run out of room there. I'm going to write it up here. So these are commutative. Because no matter which way around they go, they give you the same thing. Example 2. See, yeah, so it's got a bit cramped, isn't it? Okay, so if you want to make a note of that, let's just do it over here. So commutative. We saw for example 2, with subtraction, we wrote these 2 statements in the following way, and we saw that these, okay, for subtraction, these are not commutative. Okay, the order in which you do things does matter. Example 3, we just looked at a quick example of multiplication, and we saw that if we write this statement, we'd write it as 6x or any other letter. And the last one we looked at, example 4, we looked at division. Okay, and we wrote the following statements as such, and we saw that division is also not commutative. Okay, so that is it for this video. In fact, we're going to look at one other little thing. If you want to, sorry, you can make a quick note of this stuff here. But just one extra thing just to finish up with, which is this. How would you write? I'm thinking of a number and I add 5 to it and it equals 11. Well, we know the first part, I'm thinking of a number. Okay, it's going to be the x part or any other letter or symbol. I add 5 to it plus 5 and it is equal to 11. And that is it. Okay, and this is going to be a useful idea for the next video. Okay, and this thing here is an example of a one-step equation, right? You started at something which was x, you added something onto it, so this is the one-step part, and you got it being equal to something, and it is an equation because you have an equal sign. And we're going to be looking at how we solve equations, which this here is a really simple equation, right? It's just saying what number add 5 is 11, so you might say, well, x is equal to 6, which is fine. But understanding how to properly solve an equation when things get trickier is really important. And this is why this video is important, as you're going to find out later. Okay, so that is it for this video. Thank you for watching.